How are we doing today? Hopefully y'all are doing well. Today we are going to be continuing our notes in bonding, in those chemical reactions. And so what we're going to be looking at is physical versus chemical. All right, now for this you do need to make sure you've got your notes and something to write with, but otherwise you should be good and we can go ahead and get started. All right, so for this, first off, we need to know the difference between a physical and a chemical change, right? So physical changes are going to be changes that occur where we're still left with the same substance. Now, what do I mean by that, by the same substance? What I mean is it's still got the same properties. So it'll still melt or boil or burn or whatever it is at the same temperatures. It will still have the same physical properties, such as being able to be stretched into a wire, or when you hit it with a hammer, will it dent? Things like that are going to stay the same. That's going to be a physical change. And so a lot of times what we see when we're talking about physical changes is going to be a phase change. So remember, your phase changes would be like melting, boiling, sublimation, deposition, freezing, condensation. All of those things are going to be examples of physical changes. Why? Because they are not actually altering the substance. All we're actually doing in that case is overcoming your intermolecular forces. So your IMFs are actually going to be broken. Okay? So that's physical. A chemical change is when we actually transform the substance into something new. And as a result, we're going to have new properties. So it will become more toxic or less toxic, or it will have completely different melting and boiling points, or you'll see different properties like it becomes more brittle. Those things are all properties that are going to change because of a chemical change. Okay, so chemical changes, we're getting a new substance. And as a result of this chemical change, we're actually going to form new bonds, or we are going to break the bonds that we already have. Okay, so if I take something like sodium chloride and I separate it apart into sodium and chlorine, what we're going to have is a chemical change has occurred. Why? Because now they've got two different properties. I took sodium chloride, table salt, and I created solid metal sodium and gaseous chlorine. Okay, both of which would be horrible for you if you were to ingest them. But if you take pure sodium chloride, that table salt, we ingest it pretty much every single day. Okay, so our properties do change. Now, for a chemical change, we do need to be looking for our evidence for chemical change. And so your evidence are going to be things like production of a precipitate, or heat, or light, or an unexpected formation of a gas. We say unexpected because if I boil water, I expect to see a gas made, right? So it would be unexpected. So I mix two things together, or I decompose something like sodium chloride, table salt, and I get chlorine gas as a result, right? Another set of our chemical indicators would be color change. Again, it's got to be unexpected. If I add some purple food coloring to water and the water turns purple, did I expect that? Yes. If I took a clear liquid and a brass colored substance, I put them together and they turned blue, is that expected? No. There's completely different changes. It's got to be unexpected. Okay? All right. So that would be the difference between a physical and a chemical. Okay. Now, sometimes a physical process can actually involve the breaking of a chemical bond. Now, this is very rare, but there is some evidence to show that it can occur. An example of this would be taking table salt and putting it into water. What actually occurs is that the water molecules will actually pull apart our table salt into its individual ions. And so sometimes it's a little bit iffy on what we would classify that as. But for the most part, if we're talking about a physical process, we're going to see that actually being a physical change. All right. So the rest of this is going to be me trying to let you see how AP chemistry is going to ask questions about this. Okay. So let's take a look at this. So first off, It says, describe the changes in forces of attraction that occur as H2O phases or changes phase from liquid to vapor. So they're essentially asking what happened with my intermolecular forces when we go from a liquid to a gas. Okay? Well, what happened is the water overcame the forces of attraction, resulting in water going from liquid to gas. So in this case, they were essentially asking us, how did the intermolecular forces, how were they affected? How were those forces of attraction actually changing? And so essentially the forces of attraction are still there, right? So water molecules, we know that they've got a hydrogen bond that's forming. That hydrogen bond is actually being overcome, which causes that water to actually turn into a vapor, turn into that gas, because those molecules are moving fast enough to escape. Okay? So let's look at another example. So it says a student is performing a lab experiment and they determine that a physical change has occurred. What is one observation that could have been recorded that would prove a physical change occurred? Now, it does say one, but I do want you to list three possible changes. And so some examples of a physical change, a phase change. So it went from solid to liquid. Okay, so that would be one of my examples. Another example is when hit with hammer, it shattered. Another example would be when stretched into a wire. So when stretched, the substance tore. Okay, so instead of actually stretching into a wire, it actually just broke. Okay, so just some basic examples of physical change occurring. So it could be anything else. You don't have to put these three. I want y'all to kind of think about what are some things that you would see with a physical change occurring. Okay? All right. Another example that you could see on AP is determine whether the following are physical or chemical changes. And instead of giving you like a description of what happened, they just give you a chemical formula and you have to figure it out. So let's look at this. So I have C2H5OH, liquid, produces C2H5OH, gas. Well, we just went from a liquid to a gas, so that would be a physical change. Next, I have H2O. It went from H2O into H2 and O2. Is it the same substance? No, it's not. So this would be a chemical change. C, I went from C6H6, which was a liquid, to 3C2H2 gas. Now, there was a physical change that occurred, right? We created a gas. However, we've got completely different substances there, or a completely different substance, which would mean that it's a chemical change. Last, I took NH4Cl, which was a solid, and it produced NH3 plus HCl. And so this would be creating new substances, so it would be a chemical change. All right, y'all, so that is it on our physical versus chemical. So it is a very, very simple thing, just kind of breaking it down. I wanted y'all to see what AP Chemistry would do in terms of these concepts. So let me know if y'all have any questions. Otherwise, y'all have a great rest of the day. Bye, y'all.